Alright, we're going to take a look at the power rule when it comes to differentiation. So we're going to make a tab for it. Just 2 lines is enough. And we'll just make as many tabs as we need for whatever we're doing. So power rule, 2 tabs is enough. So go ahead and stick the paper on the left hand side. Alright, so these are the functions. These are how you write the first derivative with that prime, and the second derivative has 2 of them. Alright, so remember, derivative is another name for, or another word for slope. The derivative is another word for slope. You cannot forget that because that's imperative. So let's say we had f of x is equal to 3, a constant. That's the same thing as saying y is equal to 3. I want to prove to you the derivative of a constant is always going to be 0. So let's graph that. So y is always 3. No matter what the x value is, y is always 3. So when x is 1, y is 3. When x is negative 2, y is 3. When x is 3, y is 3. Y is always 3 no matter what x is. So it's a horizontal line. But what do you know about a horizontal line? The slope of a horizontal line is 0. The slope of a horizontal line is 0. So therefore, the derivative of any constant will always be 0. Because whether it's f of x equals 50 or f of x equals negative 3, it doesn't matter. It's always going to be a horizontal line. So therefore, the derivative of any constant will be 0. Will always be 0. Alright, so let's take a look at some examples on how to take the derivative using the power rule. Alright, so the very first thing that you do is you take the exponent term and multiply by the coefficient and write it down. So in this case, the exponent term times 4 is 16. Write it down. Write down the variable you're dealing with, which is x, and then subtract 1 from the power. So 4 minus 1 is 3. Do the same thing for every term. So same thing, this has an invisible 1. 1 times negative 5 is negative 5. Bring the variable next to it and then subtract 1 from that, so that's x of 0. Do the same thing for the other one. Well, remember, we just showed you that a constant is always going to be 0, so that's minus 0. The derivative of a constant is always 0. So let's simplify this a bit. That's going to be 16x cubed, and then x to the 0 is always going to be 1, so 1 times negative 5 is negative 5. Alright, so take the second derivative, do the exact same thing as you just did again. So take the exponent of each power multiplied by the coefficient. So we're going to do 3 times 16. 3 times 6, 18, carry 1, 3, 4, 48. Okay, so I guess I make a mistake, but it should be 48. 16 times 3 is 48. So write down 48. That's a listening check. Check if you're listening. 48. And then subtract 1 from the power is going to be 2. And then remember, constant derivative of any constant is equal to 0. So final answer is going to be 48x squared is the second derivative. Alright, let's take a look at another example. I'm just going to separate this by color because it's going to get really messy because I printed the questions out too close to one another. So I'm just going to separate them so I know which question goes with which. Alright, so to get the derivative of this, y prime, because we can write it like that, multiply the power times the coefficient, so 2/3 times 5 over 4. And then subtract x, subtract 1 from the power, so 2/3 minus 1. Alright, then go ahead and simplify it. So that's going to give me, I can simplify as an x, so that 2 and 4, 1 time, 2 times, then multiply, that's going to be 5 over 6. And then x, 2/3 minus 1 is negative 1/3. If you don't know that, you can do it on the side. Make the denominator the same, then subtract. Alright, so that gets, that's what that is. So then to get the second derivative, you're just going to do those steps again. So now you're going to multiply it by the power by the coefficient. So that's going to be negative 1/3 times 5 over 6. And then x, and then subtract 1. So negative 1/3 minus 1 is going to be negative 4 over 3. Again, if you don't know that, you could do it on the side. So let me show it to you. Make the denominators the same, then subtract. Alright, simplify that. It's going to be negative 5 over 18x, negative 4 over 3. Which is the same as negative 5 as 18x to the power of positive 4 over 3. Let's take a look at another example. So before I do this one, let me just rewrite this. Let me bring the x cubed to the top. So it's going to be 3x to the negative 3. Then multiply the power by the coefficient. So negative 3 times 3 is negative 9x. And then subtract 1, so it's negative 4. So I can rewrite that with the power back to positive by just taking it to the bottom, so negative 9 over x to the fourth. The second derivative, multiply, I'll use the power on the top, multiply that again, that's going to be positive 36, and then subtract 1 from the power, which is going to be negative 5. Then I can rewrite it as positive 36 over x to the fifth power. Alright, let's take a look at a more complicated one. Again, I'm just drawing these to kind of separate it so I know what question goes with what. Alright, so let's rewrite it first, all the square roots, so many. So square roots, and then how do I write the cube root of s to the power of 1/3, plus square root of 2, how do I write the cube root of 1/5, s to the 1/5. Now that I have that, it's easier to do. So the derivative is going to be 1/3 times the square root of 2, which is radical 2 over 3, subtract 1, then 1/5 times radical 2, s to the 1/5 minus 1. Alright, so that gives me radical 3 over 2, and then 1/3 minus 1 is negative 2/3. Plus radical 2 over 5s, and then 1/5 minus 1 is negative 4/5. I know I'm going to take them to the bottom to make them positive, so radical 2 over 3, and I'm going to write it in radical form, so cube root of s squared, plus radical 2 over 5, and then fifth root of s to the fourth power. There you go. Alright, to take the double derivative, I'm going to start with the powers that are already on the top for me. So again, multiply negative 2/3 times radical 2 over 3 minus 1 from the top, plus multiply negative 4/5 times radical 2 over 5, which is negative 4 radical 2 over 25. And I just realized I made a mistake on that first one. If I multiply negative 2/3, I would have negative 2 radical 2 over 9. I forgot to multiply the 3's together. I then subtract 1 from the s, so negative 4 minus negative 4/5 minus 1. Now let's simplify this a bit. So we're going to have negative 2 radical 2 over 9, and then negative 2/3 minus 1 is negative 5 over 3, minus 4 radical 2 over 25, and then negative 4/5 minus 1 is going to be negative 9 over 5. Alright, then go ahead and put them on the bottom. And by the way, I'm just teaching you how to do it on top or bottom because it just depends what the person is looking for. You can stop at any stage. Technically though, you're not supposed to have a radical on the bottom. So for time purposes, I'm not going to rationalize the denominator, but please remember that you can't have a radical in the denominator. Okay. Alright, so what does the power rule say? The power rule says that if you have f of x is equal to x to some n power, you're going to bring the power down to the front and multiply it and subtract 1 from it. That's the original definition. So let's do some practice example. What's the first derivative of each function? So let's say you had f of x is equal to the square root of x. The first thing is make it into a power, so x to the power of 1/2. Then bring it down, multiply it down, and then subtract 1. And then let's simplify this. Now, I said you can have a radical on the bottom, so we're going to go ahead and rationalize this. So multiply top and bottom by the radical to get rid of it. We're going to get radical x over 2x. Now you don't have a radical on the bottom. I just didn't have time to do it on, that was the space really to do it on the previous one. Number 2, let's say you had 5 over x fifths plus 3 over x squared. First thing you do is rewrite it so that its powers on the top, 5 to the x of negative 5 plus 3x to the negative 2. Then bring it down, so negative 5 times 5, subtract 1, negative 2 times 3. I'm going to put in parentheses so I can take another sign, subtract 1. Alright, that simplifies to negative 25 over x to the power of 6, I'm just bringing it down, minus 6 over x to the power of 3. Alright, so we're going to try and simplify this, make this the same denominator. So this is what we get. and there's nothing I can do further, so that would be fine. I mean, either way it's going to be okay, just depends what the examiner is looking for. Alright, let's take a look at another example. So first thing, make them the powers, so that's going to be x 2/3 plus x 1/2. Then bring the powers down, subtract 1, bring the power down, subtract 1. Alright, let's simplify, bring the x's to the bottom, 2/3x to the cube root, plus 1/2 to the square root. Again, can have those radicals. So first let's make them the same denominator. So look at both of them. What's the first one missing that the second one has? It's missing a 2, so if you do it at the bottom, do it at the top. So missing a square root of x. If you do it at the bottom, do it at the top. This other one's missing a 3, and it's missing a cube root. Do it at the bottom, do it to the top. Let's go ahead and simplify this. So we're going to have 4 radical, well, the bottom is going to be 6 square root of x and the cube root of x. The top is going to be 4 radical x plus 3 cube root of x. Alright, is there anything we can do to that? Okay, well, we can't have the radicals on the bottom, so we're going to have to rationalize it. So we're going to multiply top and bottom by square root of x and the cube root of x. And don't put that 6 because it's just going to mean we're going to simplify the end. Yeah, there you go. Multiplying out, it's going to be 4x cube root of x plus 3x square root of x. All over square root of x times square root of x will be x. Cube root of x times cube root of x will be x. Alright, so let's simplify this. It's going to be 4x and then cube root of x plus 3x square root of x over 6x squared. Entire, because I forgot to simplify. You can cancel one x. So you can cancel an x from the first term, the second term, and the bottom, leaving your final answer 4 cube root of x plus 3 square root of x over 6x. That's your listening check. Copy this example. Alright, take the second derivative of each function, bring the power down, multiply it, subtract 1. Bring the power down, multiply it, subtract 1. Derivative of constant is the same thing. Do it again to get the second derivative, bring the power down, multiply it, subtract 1. Bring the power down, multiply it, subtract 1. That's an invisible 1. Bring it down, multiply it, subtract 1. Final question. Alright, 5 times 4, 20, subtract 1, 4. 4 times 5, 20, subtract 1 is cubed. There's another listening check. I'm making all kinds of mistakes. 4 times 20 is 80, so that's another listening check. 80, subtract 1 is 3. 3 times 20 is 60, subtract 1 x squared. So those are my listening checks.